Hey guys, before we start lesson 3.3, I want to use our knowledge of systems of equations and start to solve word problems. This is a huge part of the SAT, so we need to practice these skills and make sure everyone feels comfortable using systems of equations to solve word problems. So if we look at the example we have here, it says, in the summer, football camps are offered at a discount price for new players. The prices you see below also include a one-time registration fee. What is the cost of each lesson and the one-time fee? So there's a 10-day program that is $500, and then there's a 20-day program that is $750. So step one, we want to think about the problem and relate it. Here I have 10 times the cost of one day plus a one-time fee is equal to 500. So that is referring to the 10-day program. Next, I have 20 times the cost of one day plus the one-time fee is $750, and that refers to our second option, the 20-day program. Step two, we're going to define our variables. We're going to let x equal the cost of one lesson and y equals the cost of the one-time fee. Step three is to write our systems of equation. So the first one will be 10x plus y equals 500. The second one will be 20x plus y equals 750. I got the 10 from the 10-day program and the 20 from the 20-day program. So it's basically what we did in step one, except now we're actually writing our systems of equations. Now, if we wanted to solve this system, obviously there's different ways you can do this. You can graph it, you can use the substitution method, or you can use the elimination method. Looking at our equations, I am just going to use the elimination method. So I realize that if I multiply if I multiply the first equation by -2, I will be able to cancel out both terms with the x. So I'm going to rewrite this. If I multiply by -2, I'm going to get -20x minus 2y equals -1000. Okay? And I'm going to rewrite my second equation below it so I can add them together. What I have here is my 20x's are going to cancel out, and I'll be left with -y equals -250. Okay, which really tells me that y is equal to $250. So that would be the cost, since up here we said that y is the one-time fee. The one-time registration fee is $250. Now in order to find x, I have to plug 250 into one of my equations. Let me move this up so we have more room. To find out the cost of a one-day lesson. So I am going to plug it into my first equation, which is 10x plus 250. Remember, I'm just plugging in 250 for y because we determined that y was equal to 250 equals 500. And I'm going to solve for x. So I'm going to subtract 250 from each side, and I'll be left with 10x equals 250, divide by 10, and I find that x is 25. So the cost per day is $25, or the cost per lesson is $25, and the one-time registration fee is $250. So that is one method we use to solve the system of equations. It's also a way we used our knowledge of systems of equations to solve the word problem above. Okay, so remember when you are watching these video tutorials, you guys should be taking notes. In addition to taking notes, I want you to try this one word problem out on your own. It says that you take 60 minutes to answer a combination of 20 multiple choice questions and extended response questions. For each multiple choice question, you took 2 minutes. For each extended response question, you took 6 minutes. Write a system of equations to model the relationship between the number of multiple choice questions, M, and the number of extended response questions, R. So that's the first part, is to write a systems of equations. The second part is to find out how many of each type of question was on the test. So I already gave your, I already defined your variables for you. So M is going to be the number of multiple choice questions, and R is going to be the number of extended response questions. Okay, you're gonna want to use this 2 minutes for every, I should underline that in blue so it corresponds with our M down below. Remember, it takes 2 minutes for every multiple choice question, and it takes 6 minutes for every extended response question. So there's a couple different hints. I want you to try this out on your own. If you don't get it right away, don't panic. We'll go over it in class, but I want you to at least try it. All right, so now we're going to jump into lesson 3.3. And this starts on page 348 of your iBook. And lesson 3.3 talks about systems of inequalities. So just like we dealt with system of equations previously, now we're going to talk about systems of inequalities. Okay? Again, you can solve these systems in multiple ways. Graphing is most commonly used, and you'll see why in a minute. And just know that the solution of a system of inequalities is the set of all points that are solutions of each inequality. Okay, so problem 1, we are going to use a table to solve a system of inequalities. And here's our system right here. The first inequality in the system says that g plus m is greater than or equal to 6, and the second inequality reads 5g plus 2m is less than or equal to 20. Okay, so step 1 is to make a table, which I did below. For values for g and m that satisfy the second inequality. So in other words, when g equals 0, what can m equal? Remember, it's an inequality, so you're going to have more than one value for m. So just to be more clear, if I plug in 0 for g for the second inequality, I'm going to rewrite this, plugging 0 in. Okay, and then I'm going to solve for m. So I'm going to get 2m is less than or equal to 20, and m is less than or equal to 10. If m is less than or equal to m, that is why if we look in our m column, we have 0 through 10 listed there, okay? And so on and so forth for the different values of g. Now, for step 2, we're going to look at the table and we're going to highlight each pair of values that satisfy the first inequality. So now we need to go back up and look at the first inequality to see which values to highlight. I know that I am going to end up highlighting 6 through 10. And I'm sorry, I know it's kind of hard to see. Because let's look at this a little bit closer again. If I plug in 0 for the first inequality for g, then I'm going to have 0 plus m is greater than or equal to 6. So basically, m must be greater than or equal to 6. And that's why I highlighted 6, 7, 8, 9, and 10. Okay? Because those are the values that I already have on the table that satisfy both inequalities. Okay? If I did that for when g equals 1, I'm going to end up highlighting 5, 6, and 7, okay? If I plugged in 2 for g for the first inequality, the values that we see in our table that satisfy that inequality are only going to be 4 and 5, okay? Now I'm not going to highlight anymore, and I'll show you why. If I plug in 3 for g in my first inequality, right? So 3 plus m is greater than or equal to 6. I'm going to solve for m, so I'm going to subtract 3 from both sides, and I'll get that m is greater than or equal to 3. Because m is greater than or equal to 3, look right here, my when g equals 3 column, I don't have anything greater than or equal to 3, so I can't highlight anything. And the same thing will go for the column below when g equals 4. Okay? The highlighted pairs, okay? Now when I say pairs, I mean, let's look at the first column, or the first row, I should say, when g equals 0, we're going to write those as ordered pairs, okay? So, for instance, 0, 6, okay? 0, 7, right? This is all that's highlighted in that first row. 0, 8, 0, 9, 0, 10. All the highlighted pairs equal the solutions of both inequalities, okay? If I was to rewrite, or if I was to write out all of the pairs, I just have to create some more room here if this chooses to work, okay? So now I can include when g equals 1, I highlighted 1, 5, 1, 6, and 1, 7, and when g equals 2, I highlighted 4, and I highlighted 2, 5, okay? So all of these ordered pairs that you see here, I'm going to circle them in blue, are the solutions to the system of inequalities that we started with. Okay, now before we go any further, I want to remind you guys that when we graphed inequalities before, right, their solutions consisted of a half plane and possibly its boundary line. In other words, we would shade a half plane on our graph, and sometimes we would include the boundary line or not, and that would be our solution. But when we're comparing two inequalities or two inequalities of a system, the solution is going to be the overlap of the two half planes. And I'm gonna give you an example right now just to make this clear. So let's say that I want to graph y is greater than or equal to -2 plus, negative 2x plus 4. Okay, if I was to graph that now, this obviously is not going to be perfect, but I know my y-intercept is at 4. I also know that my slope is -2. So I'm going to come down to over 1, come down to over 1, come down to over 1, okay? Now, in order to find out which part to shade, we would plug in a test point, and we always use 0, 0 unless it falls on the boundary line. So if I plug in 0 for x and y, I'm going to be left with 0 is greater than or equal to 4. This is false, okay? 0 is not greater than or equal to 4, so I'm not going to include 0 in my shaded area. So I'm going to shade this part of my graph. But now let's say I ask you to graph another inequality, right? So let's graph y is less than or equal to x plus 2. Maybe I should do this one in red. Okay, so if I'm going to graph y is less than or equal to x plus 2, my y-intercept is going to be at 2, and I know that my slope is 1. and it's going to be positive. So I'm going to go up 1 over 1, up 1 over 1. Okay, I'm going to graph this line. Again, I need to plug in a test point. I'm going to use 0, 0. And I will get that 0 is less than or equal to 2. That is true, right? 0 is less than or equal to 2. So I am going to include that. I want to include 0, 0 in the part I shade. Okay. Now remember, the solution is the overlap of the two half planes. Where do my two graphs overlap? If we look closely, they overlap right here in this section that I just colored in blue. Okay, that's where the two graphs of the inequalities overlap. Therefore, this portion that I just shaded in blue is going to be the solution of the two inequalities we just graphed. Okay, so here we have another example of graphing. This is the last one we're going to do, and then I'll let you guys go, but let's run through these steps one more time. I give you the system of inequalities right here, right? Oh, sorry guys, let me redo that. I give you the systems of inequalities right here, where it's 2x minus y is greater than or equal to negative 3, and y is greater than or equal to negative 1/2 x plus 1, okay? So before we do any graphing, we have to rewrite our inequalities in slope-intercept form. The second inequality is already in slope-intercept form, but let's do this first one here. It's going to be negative y if I add 2, or if I subtract 2x from both sides, is greater than or equal to negative 2x minus 3. I'm going to divide everything by negative 1 because I want y to be positive. So I'm going to flip my sign, and I'm going to be left with y is less than or equal to 2x plus 3. Okay, so now I have both of my inequalities in slope-intercept form. Step 2 is to graph them. Now this is going to be hard on the iPad, but I'm going to do my best, and you guys are going to do a way better job because you actually have real graph paper. Okay, so let's see if we can do this right. Okay, if I look at my first inequality, I see that, let me do this one in red. I see that my slope-intercept is 3 and my slope is 2. So I'm going to go up 2 over 1, and I'll work backwards this way. Okay, because it's greater than or equal to, or I'm sorry, less than or equal to, I'll have a solid line. Now let's do a test point to figure out which part of the graph I shade. I'm going to plug in 0 for both y and x and see if it's true or false. So if I simplify, I'm going to get 0 is less than or equal to 3, which is true. So I want to include 0, 0 in my shaded portion. So we'll shade that red. Okay. All right, let's do the second one, and we will do this in blue. So looking at y is greater than or equal to negative 1/2 x plus 1, I know that 1 is my y-intercept, and my slope is negative 1/2. So I'm going to come down 1 over 2, down 1 over 2, and I'll go this way. Okay, it is greater than or equal to, so I'm going to have a solid line. Again, we have to plug in a test point to see which portion we're going to shade here. And I'm going to get that 0 is greater than or equal to 1. That is false. I don't want to shade in, or I don't want to include 0, 0 in my shaded portion. So I'm going to shade, if my pen wants to work, I'm going to shade here. Okay. Remember, we are looking for the overlap in the two graphs. That's going to be our solution. So where does my graph overlap? From here to here. Okay, let's try this again. From here to here is where we see this overlapping. So this portion of my graph is going to be the solution. Remember, if you have any questions, the first thing you should do is go back and rewatch the video. If we still have questions, don't forget your iBook is a great resource to look through. And then also come to our next class meeting with any questions, and I will try and answer them. And we'll spend more time on this in class. I just wanted to introduce these systems of inequalities, okay? Please make sure you try that first word problem before we got into lesson 3.3, and also come with notes so I can check them for a homework grade. Have a great night.